today's lecture, we are going to study about relation between different current gains. Till now, we have seen three different configurations with three different current gains, that is alpha, beta, and gamma. Firstly, we are finding the relation between alpha and beta, and then we are going to find the relation between alpha, beta, and gamma. Starting with our first relation, that is the relation between alpha and beta. Initially, the first equation that we know, that is your emitter current, that is equal to the summation of your base current plus collector current. Dividing this equation with IC, that is collector current, will be having IE by IC, that is equals to IB by IC plus 1. Now we know that IC by IE, that is equals to alpha, and IC by IB, that is equals to beta. Placing this value in this equation, we can say that here we are having IE by IC, that is 1 upon alpha. So we have placed 1 upon alpha over here. This is that is 1 by beta. So we have written 1 upon beta and this one as it is. Solving this by taking the LCM, that is equals to beta plus 1 by beta, and finding the value of alpha, that is reversing this term, will be giving alpha, that is equals to beta upon beta plus 1. This is our first equation, that is called as alpha in terms of beta. Now we are finding the equation of beta in terms of alpha. Simply by multiplying alpha with beta plus 1, we are having alpha, that is equals to beta plus 1 equals to beta. Opening the brackets, we are getting alpha beta plus alpha is equals to beta. Taking beta common from these two terms, that is beta is equals to 1 minus alpha is equals to alpha. Finding beta, that is beta is equals to alpha upon 1 minus alpha. This is our second equation, that is showing the value of beta in terms of alpha. So this was the relation between two current gains, that is alpha and beta. Now we are finding the relation between alpha, beta, and gamma. Here, first of all, we know the equation for alpha, that is IC by IE, beta, that is IC by IB, and gamma, that is IE by IB. Okay, first we are having this equation, that is a common equation of the current, that is IE equals to IB plus IC. We are just written in the form of change in emitter current, that is equals to change in base current plus change in collector current. From this, we are finding the value of IB, that is equals to IE minus IC. Placing this value of IB in this equation of the gamma, that is change in IE is remaining as it is, and instead of this, we are placing this equation. Okay, we are placing the value of IB over here. So that is minus IE, change in IE minus change in IC. Now dividing this whole term with IE, will be getting 1 upon 1 minus IC by IE, and this is termed as alpha. So gamma, that is equals to 1 upon 1 minus alpha. This is our first equation, that is gamma in terms of alpha. Now simply we are placing the value of alpha, that is beta upon 1 plus beta, which we had found in the previous equation. Placing that value over here, finding the LCM and solving this equation, we are getting the equation of gamma in terms of beta, that is equals to beta plus 1. This is our second equation of gamma in terms of beta. So these are the two current gain relations, that is alpha and beta. First relation that was between alpha and beta, in which we had find the value of alpha in terms of beta and beta in terms of alpha. And the second relation, that is the relation of gamma with alpha and beta.